Hello class 11th, welcome to lecture number 2 of Relations and Functions chapter. Today we are going to learn about functions. If you haven't yet seen lecture number 1, then you have missed the introduction of relations. And if you have missed introduction of relations, then it will be a little difficult to learn how a relation can be called as a function. Okay, so do watch lecture number 1, 2. And today we will also be completing this chapter because this chapter is all about relations and functions only. Alright, now, so I am Sana Khan, your maths master teacher, and every day I take lectures of mathematics on this channel of Vedantu Malayalam. Okay, so guys, if you are somebody new on the channel, don't forget to subscribe, because if you don't subscribe, you won't get the daily notifications, right? And you won't be able to know that what is our daily schedule. So how will you be regular, right? So do subscribe and hit the like button. It gives us lots of motivation. Now, yesterday we discussed about the syllabus of this chapter. So hope it's clear to you what is included, what is not included in the chapter. Now, in the lecture number 1, we have already completed the following topics. What are relations, what is Cartesian product, and basically domain, range, and some typical cardinality of relations. Okay, now in today's class we are going to learn all about functions, the different types of functions, and algebra of functions. All right, this is not improvement class beta, this is regular +1 class. As you know, +1 has already started in almost all the schools, and this is your session 2023-24. All right, of course, if you are taking drop and you are preparing for your competitive exam, then also this session is useful for you. Okay, cool. So should we start our class with the discussion of functions? Let's get started. Now, functions and relations have a very important relation. Do you know what is that? Well, basically, we have learned yesterday that relations are nothing but subset of Cartesian product of two sets. Yesterday we saw that if I am taking Cartesian product of two set A cross B, then relation is basically a subset of that Cartesian product. Now, do you know that a function is like a subset of the relation? So basically, a relation can be called as a function based on a certain criteria. And what is that criteria? So a relation from a set A to a set B is said to be a function if every element of set A has one and only one image in set B. What does that mean? Suppose I have two sets. Let's take example of set A described as A, B, C. Set B having elements 1, 2, 3, 4. Okay. Now I am saying that A is mapped with 1. B is mapped with related to 2. C is related to 3. So I have basically a relation which is having ordered pairs A1, B2 and C4, C3. Now can I call this relation as function? Let's check the criteria. The criteria is saying that a relation can be called as a function if every element of set A has only one image in set B. Is it following the criteria? Yes, A is having only one image, that is 1. B is having only one image, that is 2. C is having only one image, that is 3. So, this relation is a function. Yes. Now, similarly, if I take another relation where I have ordered pairs A1, B2, C3, C4 and that's it. Okay. Now, is every element in set A having only one image in set B? Here the criteria is not getting fulfilled. Why? Because C has an image 3, C has an image 4. So C is mapped with 3, C is also mapped with 4. So is this a function? This is not a function because C is mapped with 3 and 4. A single element cannot have more than one image and this relation cannot be called as a function. Clear to all of you? What are functions? So in other words, a function is a relation from a non-empty set A to a non-empty set B such that the domain of the function is A, that is our first set, and no two distinct ordered pairs in the function have the same first elements. So if I am defining a relation here where I have ordered pairs, for example, I have A1, B1, I have A2, B2, I have A3, B3. So every element is having a different ordered pair. Every element is having a different first element. They are not having same first element. So this can be called as a function. Now if I have another relation where same first element is there. For example, A1 with B1 and A1 with B2. Is this a function? This is not a function because the first element is same in the two given ordered pairs. I have two ordered pairs and both the ordered pairs have same first element. So it is not a function. Clear? What is function? Alright. Now, when we are talking about function from a set A to a set B, then the ordered pair AB belongs to the function such that f of A is equal to B, where B will be called as the image of A under F and A will be called as the pre-image of B under F. Okay, let's take one example. The function f from A to B denoted by, it is also denoted like this, f colon A arrow B. This denotes the function is defined from set A to set B. Now, how can you define the function? You can say that f of x is x plus 2. Okay. So, if your set A is having 1, 2, 3, set B will have the image. So, 1 plus 2, 3. Okay. 2 plus 2, 4. 3 plus 2, 5. So, here you can see that f of 1 is 1 plus 2 is equal to 3. F of 2 is 2 plus 2 is equal to 4. F of 3 is 2 plus 3 is equal to 5. So, here these elements are called as pre-image and these numbers are called as image. Understood? Alright. Let's do a quick question based on the concept. Let n be the set of natural numbers and R be a relation defined on natural numbers such that the relation is having ordered pair xy where y is equal to 2x. What is the function? The function is defined as the image is basically twice of the pre-image. What is the domain, what is the codomain, and what is the range of the relation? And is this relation a function? Let's find out. Now, I know that if I take my domain will contain all natural numbers, all the natural numbers, because the relation is defined on natural numbers. Okay. My codomain will contain all natural numbers. But My range will contain what? Can anyone tell me? Only even natural numbers. Why is this happening, guys? Why only even natural numbers are there? Let's find out. So they are saying that my domain is 1, 2, 3, 4, dot, 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 dot. My codomain is again having elements like 1, 2, 3, 4, 5, 6, dot, 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 dot. Now, what is 1 into 2? 2. 2 into 2? 4. 3 into 2? 6. So, my range is having 2, 4, 6. This is my range. That is, my output is only even natural numbers. So my range is basically only even natural numbers. It is not going to contain any odd natural number. Okay. Now lastly they are asking, is this relation a function? Can anyone quickly tell me, is this relation a function? Yes or no? Come on. Tell me in the chat box. Is this relation a function? Just tell me. Yes, no, what do you think? Is this relation a function? Well, the answer is yes. It is a function because every pre-image is having a different image. Every image is having a different pre-image. Right? Pre-image of 2 is 1. Pre-image of 3 will not be 1. No two elements will have same first element because no two natural numbers have same double. है ना? It's not like 2 2s are 4, 3 2s are 4. It will never happen. Right? So the answer is yes, it is a function. Okay, now an easy peasy question for all of you. Examine each of the following relations given below and state in each case, giving reason whether it is a function or not. Come on, tell me. First one. Is this a function? Yes or no? How will you find out it is a function or not? Just check the first element. 2, 3, 4. Are they different? Yes, they are different. So we will say yes, it is a function. All first elements are different. Right? Second one, can you tell me, is this a function or not? We will check. 2, 2, 3, 4. Is this a function, yes or no? No, it is not a function. Why is this not a function? Because 2 comma 2 and 2 comma 4 have same first element. Both 2, 2. It's wrong. It cannot happen. Third one, 1, 2. So basically 1, 2, 3, 4, 5, 6. Is this a function? Yes. It is a function because all the first elements are different. Understood? Easy to answer, right? Oh, we had more space. Okay. So, pretty simple question. Alright, now moving on to some different types of functions that we see in our day-to-day mathematics. First of all, there are two types of functions, real valued functions and real functions. Now, what are real valued functions? If a function has either real number or one of its subset as the range, then it is called as real valued function. For example, if your function is defined from like any set A to basically real numbers, okay, or a subset of real number. What is a subset of real number, guys? Integers, rational numbers, whole numbers, natural numbers, anything. Okay. Now, what is a real function? If the function is defined from real numbers to real numbers, that is from basically a subset of real number to a subset of real numbers, then we say that it is real function. Okay. Now let's learn about some real functions that we use a lot in our mathematics. First is identity function. What is identity function? F of x is x. That means what? F of 1 is 1. F of 2 is 2. F of 3 is 3. Okay. So here if you see the graph, x is equal to 2, y is 2. X is equal to 4, y is 4. X is equal to 6, y is also 6. So for every input we get same output. And here what will be the domain and the range? The domain and range will contain all the real numbers, because every real number will have same real number as the output. Minus 1 output minus 1. Minus 100 output minus 100. So same to same domain and range, all the real numbers. Okay. Next, constant function. What is constant function? If the function always results in same constant. For example, here I see that f of x is 3. It means what? If I put x is equal to 1, I get 3. If I put x is equal to 2, I get 3. If I put x is equal to minus 1, again I get 3. So output is always 3. Output is always same constant number. Then that is called as a constant function. Easy? Okay. Next is polynomial function. Polynomial function is a function where power of every variable is a non-negative integer. Non-negative integer is basically whole numbers. So you can also say that the power is always a whole number. Okay. Once again, guys. The power is always a whole number. Okay. Yeah. So, polynomial functions example, if f of x is x square plus 3, f of x is 2x to the power 4 plus x to the power 3 minus x square. Any function where the power of variables is always a whole number, right? Next is rational functions. Any function which is of the form f of x upon g of x, where fx and gx are polynomial functions and gx is not equal to 0. That is, denominator should not be 0. Such functions are called as rational functions, right? Now, how do you define, can you give example of rational function? For example, x cube plus 3 divided by 2x. This is a rational function, but you should mention x should not be 0, right? Similarly, suppose you have x plus 2 divided by 4x square plus 3. Condition, 4x square plus 3 cannot be 0, right? So, such functions are rational functions. Next is modulus function. Very, very famous and very, very used function is modulus function. It basically says that it is written like this, and it says that the value of the function will be x itself for all positive integers including 0, and it will be minus x for all negative integers. Okay. Not integers, basically real numbers. For all positive real number, the answer is positive. For all negative real numbers, the answer is negative. Okay. And lastly, we have signum function. Signum function basically says that for all x greater than 0, output will always be 1. For all x less than 0, output is always -1. And for x is equal to 0, output is always 0. Okay. So here the domain is all the real numbers, but the range is only -1, 0 and 1. Alright. Okay. A quick check question for all of you. Find the domain and the range of real function f defined by f of x is equal to modulus of x minus 1. Can you tell me what will be the domain and range of this function? See, for mod function, domain is always all real numbers. You can put anything, na? 1 by 2, 1 by 3, -1, anything. But what will be the range? The range will not be negative. The range cannot be negative. Modulus function is always positive. So here the domain will be, very good Johan, all real numbers, but range is only positive real numbers and 0. You cannot forget 0. It can be 0 also. 1 minus 1, 0. So it is all positive real numbers and 0, because 0 is neither positive nor negative. Na? So we can't ignore 0. We can't exclude it, and it will be included. Okay. Now, a quick question for all of you. Is this given relation a function or not? Quickly comment. This is your homework. Okay. Now, let's learn about algebra of real function. Now, algebra is basically what? The basic operations of mathematics. Addition, subtraction, multiplication and division. So, how do you add two real functions? Very simple. F plus g of x is nothing but f of x plus g of x. So, suppose your f of x function is x square and your g of x function is 3x. So, what will be f plus g of x? It will be nothing but x square plus 3x, like this. Okay. Now, when you are doing subtraction, so f minus g of x will be basically x square minus 3x, because we are subtracting. Similar, multiplication by a scalar quantity is very simple. You can directly multiply the scalar quantity with the function. For example, if f of x is 4x cube and you have a scalar number -3, so alpha f of x will be 4x cube into -3. 4 3s are 12x cube. That's multiplication by a scalar. Next, how can you multiply two real functions? It is again very simple. You can directly multiply the two functions. Okay. So, for example, if f of x is x square plus 3, if g of x is 4x, so f into g of x will be x square plus 3 into 4x. So it will be x square into 4x, 4x cube, 4 3s are 12x. That is how you multiply. Alright. Similarly, you can divide also two functions, but remember the denominator cannot be 0. Every time you have to remember the denominator cannot be 0. Okay. Now let's do some questions. Suppose your function f of x is x square, your g of x function is 2x plus 1. Find f plus g of x. So When you add the two functions, what will you get? You will get x square plus 2x plus 1. This is nothing but x plus 1 whole square. Next, when you subtract the two function f minus g of x, you will get x square minus 2x minus 1. When you multiply the two functions, f into g will be x square into 2x plus 1. So this will be x square into 2x cube plus x square, right? Lastly, when you divide the two functions, you will get x square upon 2x plus 1 such that 2x plus 1 is not equal to 0. This is very important. Don't forget to mention that. They will cut your marks, okay? Do mention that the denominator will not be 0. Cannot be 0. Okay? Alright, here is your another homework question. Comment the answer quickly. Let me see who all can solve it. Okay. Now it's practice time. Let's practice and some questions and see if you have understood the chapter well or not. Question number 1. What can be the domain of this function? Now this is a rational function. This is what? Rational function. Now what is the criteria for a rational function? Denominator cannot be 0. So domain of f of x will contain real numbers such that x square minus 5x plus 4 is not equal to 0. Now this is a quadratic equation. You have to solve it for the value of x. To solve it, x square minus 4x minus x plus 4 not equal to 0. X common, x minus 4 minus 1 common not equal to 0. X minus 1 into x minus 4 is not equal to 0. So x cannot be equal to 1 or 4. So therefore, domain of the function f of x will contain real numbers such that x is not equal to 4 or 1. It will contain all the real number except 4 and 1. So you can also write it like domain will be real numbers minus 4 and 1. All the real number except 4 and 1. Okay. Next question. Set A has 5 elements 9, 10, 11, 12, 13. Let a function be defined from set A to natural numbers. Defined by, the function is defined as highest prime factor of n. Highest prime factor of n, find the range of the function. So, here they have given you input. This is your input. They are asking what will be the output. What is the output? Simple. Output is nothing but the highest prime factor of the given number. So, what is the highest prime factor of 9? Can anyone tell me? F of 9 means highest prime factor of 9. What is the highest prime factor of 9? Tell me. Which numbers can divide 9? 1, 3 and 9. And which is the prime number? 3. Okay. F of 10. What is the highest prime factor of 10? 5. Highest prime factor of 11? 11. Highest prime factor of 12 is 3. Highest prime factor of 13 is 13 because 13 is itself a prime number. So what is the range containing here? The range basically includes 3, 5, 11 and 13. Only 4 numbers. 3, 5, 11 and 13. Because 3 is again repeated. So we don't write repeated number in the range. Interesting question, right? Next question. Let A be the set 1, 2, 3, 4. B be the set 1, 5, 9, 11, 15, 16. And the function f is defined like this. Is f a function from A to B? Can I call this as a function? Please tell me. Is this a function, yes or no? Come on. You have to tell me. Is this a function, yes or no? Is this a function? Let's check. 1, 2, 3, 4, 2. Oh, 2 again. Okay. And here I have 5, 9, 1, 11. 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Now I can clearly see that 2 is mapped to 9 as well as 2 is mapped to 11. So 2, 9 and 2, 11 have same first element. And what will happen if two ordered pairs have same first elements? This implies that f is not a function. It is not a function because both the ordered pairs have same first elements. It should not happen, right? Okay, next question. Let f be a function 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. This function from integers to integers defined by f of x such that f of x is ax plus b for some integers a and b. Determine a and b. How will you determine a and b? They are saying that the function is defined when x is the input, output is ax plus b. Here I can clearly say this is input, this is output, right? Input, output. So let me take any ordered pair. So I know that when I am putting f of 1, I am getting 1 as the answer. So what is f of 1? F of 1 is a into 1 plus b is equal to 1. So a plus b is 1. Similarly, f of 0 is minus 1. So a into 0 plus b is minus 1. That means b is equal to minus 1. Now if b is minus 1, this implies that a will be what? 2, because 2 minus 1 will be 1 na? And we got the answer. So if you take any two ordered pairs, you will get two equations and you will get the value of the two variables a and b. Alright guys, so that's all for the day. Hope you have understood all the questions and all the logics of relations and functions chapter. So we have basically completed the chapter. Today we learned about what are functions, what are real valued and real function. We saw some special function and their graphs and algebra of functions. Let's quickly do a mind map so that your revision is also done. Okay. So what is a function? A function is a relation that maps every element of set A with only one element of set B. Domain, codomain and range of a function is, for a function A to B, the set A is called as domain, set B is called as codomain, and set of all images of A under the function are called as range of the functions. Right? Now here, Suppose this is our example. Here we have the codomain. Codomain is basically all the numbers present over here. 2, 3, 4, 5, 6, 7. Domain is having again all the numbers given 5, 6, 7, 8, 9. But what is the range? The range is only the numbers which are output. So 2, 3, 4 and 5. Alright. Next we learnt about some standard functions. Identity function is a function where f of x is x itself, domain will be real number, range will also be real number. Modulus function, domain is all the real numbers but range is only positive real number with 0. Signum function, domain is all the real number but output is always 1, -1 or 0. And greatest integer function, the domain is all the real numbers but the output is only integers, right? And lastly, we learned about algebra of real function. F plus g of x is f of x plus g of x. F minus g of x is f of x minus g of x. F into g of x is f of x into g of x. This is basically k into f of x and f of x upon g of x such that g of x is not 0. Alright guys, so chapter number 2 is also complete. We will start chapter number 3 from tomorrow. So stay tuned. We'll meet again 8 p.m. same time tomorrow again. Okay. Also, don't forget to follow us on Telegram channel too. We provide notes of every lecture on our Telegram channel and notifications and all the informations are shared over there itself. So do subscribe. And if you are new on the channel, hope you have already hit the subscribe button. Join the channel and be a part of our amazing family. Thank you for watching the video. Do hit the like button if you enjoyed and see you tomorrow same time for third chapter. Bye guys. Bye bye. Take care.